Hello viewers, this is Quadratic now taking you through the story of A-level subsidiary mathematics. And this video, we're going to go through the marking guide of beginning of term 3 exam for subsidiary mathematics of studying school where I happen to be a teacher. So we shall start with question 1. Question 1 says, without using a calculator, evaluate this expression. So we shall come and first rewrite the expression, then we simplify. Now we shall first leave 10 there, and remember that 40 is the same as 4 times 10, then 20 is the same as 4 times 5. Then from there we shall split this, so this one is the same as square root of 4 times square root of 10, but square root of 4 is 2, that's why you see 2 there, and square root of 10 remains. Then square root of 4 here is 2, and square root of 5 remains. Then next I will collect like terms, because 4 times 4, 2 times 2 is 4, and this 4 plus 6 is 10, that is why you see here 10 root 2, sorry 10 root 10. Then root 2 times root 5 is the same as square root of 2 times 5, which is square root of 10, that is why you see 10 there, and the 2 is there. So next you realize that this root 10 can cancel with this root 10, and this 10 divided by 2 gives you 5. So basically that is what they wanted. Now let's see how much can be awarded. So M1 for the simplifying numerator, M1 for simplifying denominator, B1 for the output of numerator, B1 for output of denominator, and A1 for the final answer. So that was question 1. Now we shall go to question 2, which says the mean of 8 numbers, these are the numbers, is 9. Find the value of k and the standard deviation. So you know that the mean is the same as sum of all data values divided by the number of data values. So all these ones, you add them, then you divide by the number of data values. So this is 1, 2, 3, 4, 5, 6, 7, 8. That is why you see 8 there. But the mean is 9, so you equate it to 9. The next is to simplify and then cross multiply, and after that you make k the subject. So basically that's what they wanted. So M1 will be for this substitution, A1 for the value of k. The next was standard deviation. So standard deviation, you have to first get the summation of x squared. So summation of x squared will be equal to 708. Then I remember the formula for standard deviation is square root of summation of x squared divided by n minus the square of the mean. So I'll come and substitute. Summation of x squared is 708, n is 8, and mean was given in the question as 9. So in the end I'll come up with 2.7386. So B1 will be for getting summation of x squared, M1 for this substitution, and A1 for the output. So that was question 2. Now we shall go to question 3, which says that evaluate this integral. So the first thing to do is to split the numerator. So when I split it, it will be this divided by this minus this divided by this, as you can see it here. Then next is to simplify. This one, these two cancels. Then this one is divided by this is same base, so you subtract the powers. Therefore 4 minus 2 is 2. That is why you see x squared there. For this one, 6 over 2 is 3. That's why you see 3 there. Then this divided by this, it is same base, subtract the power, so 5 minus 2 is 3, that's why you see x cubed there. Then after splitting the numerator, it means that this one is the same as this, therefore this integral is the same as that integral. Then next we shall use the rule of integration, that you increase the power by 1 and divide by the new power. So this was 2, you increase the power by 1 to become 3, divide by 3, which is the new power. Then this was 3, increase it by 1 to become 4, divided by 4, which is the new power. And that simplifies to this. The next is to substitute the limit. Begin with the upper limit where there is x, put there 2 to come up with this bracket, minus. Substitute the lower limit where there is x, we put -1 to come up with this bracket. Then I'll use a calculator to simplify. This gives me that, this gives me this, this gives me this, and this gives me that. Then when I simplify further, this bracket gives me this and this bracket gives me this. And when I simplify further, this minus this gives you negative 33/4, which is the same as negative 8.25. So basically that is what they wanted. Now let's see how marks can be awarded. So B1 for splitting the numerator, M1 for integrating this term, another M1 for integrating this term, M1 for substituting limits, A1 for the output. So that was question 3. Now we shall go to question 4. Question 4 says, a school students' council consists of 7 girls and 5 boys. 2 students are selected at random from the council. Find the probability that both are girls and 2. First is a boy and second is a girl. So the first thing to realize that this one needs a tree diagram. So we shall draw a tree diagram, 7 girls and 5 boys. So the first branch will be like that, with 7 girls over the total, which is 12, and 5 boys over the total, which is 12. The next branch will be that. So after removing the first girl, the remaining girls will be 6, so it will be 6/11, and these boys are still the same, 5/11. Then for this branch, after removing the first boy, the number of boys will reduce to 4. That is why you see a 4/11, but the girls will remain, which is 7/11. The next we shall answer the question. They wanted the probability of both girls, meaning the first is a girl and second is a girl. Therefore, first is 7/12, second is 6/11. So when I multiply the 2, I'll come up with 7/22. Then part B, they said first is a boy and second is a girl. Therefore, first is a boy, second is a girl. Therefore, this probability of first boy is 5/12, second girl is 7/11. So when I multiply the 2, I'll come up with 35/132. So basically, that is what they wanted. Now let's see how marks can be awarded. B1 for the tree diagram, M1 for substitution, A1 for the output, M1 for substitution, A1 for the output. So that was question 4. Now we shall go to question 5, which says, determine the equation of the tangent to the curve this at the point x equal to 2. So that means that the first thing to remember is that for you to get the gradient, you have to differentiate in order to get the gradient function. Therefore, the gradient function will be got by differentiating this y. So when I differentiate, I'll come up with differentiate 2x cubed gives me 6x squared. Differentiate 3x gives you 3. But that is the gradient function. Therefore, to get the gradient, you have to substitute for x. But before we substitute for x, let's first get the corresponding value of y for this x. So when x is 2, come and put 2 and 2 here to be able to get the value of y as 22. Then the gradient, it means that you substitute this x equal to 2 here to come up with the gradient as 27. So that gradient is the gradient of the tangent. Now that we know the gradient and the coordinate of one point, we can easily get the equation of the tangent from changing y over changing x, equated to the gradient which you have got here. Cross multiply and make y the subject, and that will be the answer they wanted. So M1 for derivative, B1 for the y value, B1 for the gradient, M1 for substitution, A1 for the output. So that was question 5. Now we shall go to question 6, which says that the table below shows the enrollment of students in an institution over a period of 5 years. So these are the enrollments. Calculate the 3-year moving averages, and part B, the number of students enrolled in 2008, given that the 4th moving average is 203. So moving averages are easily got by tabulating. So we are going to tabulate. First will be the number of years. The next are the number of students enrolled, and we call them points. So here we put x because it is unknown and it's the one we want. So next will be the 3-year moving totals. So moving totals means that you pair 3, 3. So this 3, the sum of those 3 is that. Then after that, you remove this one and add another one to get these 3. The sum of those 3 will be that. Then you remove this one and add another one, so the sum of these three will be that. Then you remove this one and add another one, so the sum of these three will be that. So then next will be 3 are moving averages. So moving averages you divide by this number, which is 3. So 497 divided by 3 gives me that. So we round off to 2 decimal places. Then this one divided by 3 gives you that, and this divided by 3 gives you that. This divided by 3 gives you that. So basically that's what they wanted in part A. Now we shall go to part B. So for part B they told us that the fourth moving average is 203. So this is 1, 2, first, second, third, fourth. So this fourth one is equal to 203. Therefore we shall come and equate it to 203 and make X the subject. Now this is what they wanted. I think you can see it here in the table. So B1 for this column, B2 for this column, M1 for this column, M1 for this substitution and equating, and A1 for the output. So that was question 6. Now we shall go to question 7, which says, given that vector A is 5, negative 12 and vector B is negative 3, 4, find part A the dot product of A and B, and part B the angle between the vectors A and B. So dotting A and B, so here we shall substitute for A and for B. So dotting means you multiply, so this times this gives you negative 15 plus this times this gives you negative 48. So when I use a calculator I'll come up with negative 63. So basically that's what they wanted in part A. Now part B, the angle between the two vectors, you have to first know the magnitude. So magnitude of A will be given by that formula and it will be 13. Magnitude of B will be given by that formula and it will be 5. The next is to quote the dot product formula. Then I'll substitute A dot B is negative 63, magnitude of A is 13, magnitude of B is 5, and theta is the angle which is required. When I make cos theta the subject, it will be cos theta will be equal to negative 63 over 65. Therefore theta is 165.75. So basically that is what they wanted. So M1 will be for dotting, A1 for the output, B1 for both M1 for both magnitudes, M1 for the substitution, A1 for the output. So that was question 7. Now we shall go to question 8, which says a particle moves with velocity v, which is that where t is the time. The particle is at the origin when t is 0. Find the expressions for the distance and the acceleration in terms of t. So distance or displacement is got by integrating velocity. So when I integrate this velocity, I'll come up with that. So integrate 2t squared is that, integrate 90 is that, integrate 10 is that. But remember to add the constant of integration. The next, remember that when t is 0, the particle is at the origin, meaning s is also 0. So when I substitute for s and for t, I'll come up with 0 equal to 0 plus c, therefore c is 0. So when I come and substitute for c here, s will be equal to that. Then for acceleration, you have to remember that acceleration is got by differentiating velocity. So when I differentiate this, I'll come up with 40 minus 9. So basically that is what they wanted. So M1 for this definition, B1 for this integration, B1 for the value of C, A1 for the expression, and this for the expression. So now we shall go to question 9, which says the table below shows the marks obtained in Submath and Physics by 9 students. So this is the table. Part A, Roman 1, draw a scatter diagram for the data. Roman 2, on your scatter diagram, draw a line of base fit. And Roman 3, use the line of base fit to estimate the value of x when y is 55. And part B, calculate the Spearman's rank correlation coefficient and comment on your result. So questions of correlation are easily done by first tabulating. So we are going to first tabulate our values. So values of x will be the first row. So these ones, like we see, submath is x, so all these values are for x. Therefore shall come and rewrite them. So when I add all those values, I come up with 507. Then next will be values of y. We are going to list down all the values of y. Then when you add all of them, it will be 463. The next is to put the ranks of x. Now ranks of x, ranking is done starting from the highest going to the lowest. So of these values, we are going to look for the highest. So the biggest will be this. So to take rank 1, secondly it will be 64, which takes rank 2, followed by 62, which takes rank 3, followed by 61, which takes rank 4, followed by 56, which takes rank 5, followed by 54, which takes rank 6, followed by 51, which takes rank 7, followed by 47, which takes rank 8, followed by 44, which takes rank 9. So those are the ranks of x. Now next will be the ranks of y. So ranks of y, the highest is 59, which takes rank 1, followed by 58, which takes rank 2, followed by 56, which takes rank 3, followed by 54, which takes rank 4, followed by 53, which takes rank 5, followed by 49, which takes rank 6, followed by 46, which takes rank 7, followed by 45, which takes rank 8, and lastly 43, which takes rank 9. So after that, we are going to generate a column of d. D is the deviation, so it's good by subtracting rx minus ry. So this minus this gives you that, this minus this gives that, this minus this gives you that, this minus this is 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 that, and this minus this is that. So next is to generate a column of d squared. So we shall square all these values. So when we square, this gives you this, this is that, this is that, this is that, and this is that, this is that, this is that, this is that, this is that. So next is to add all these values. So when I add all these values, I'll be able to come up with a total of 4. So before we go to the next slide, let's see marks for this table. So M1 for the column of that, B1 for the column of that, M1 for the column of d squared, and M1 for the summation. So after that, we shall remember that they told us the first question was drawing a scatter diagram for the data. So we have already got the summation of x, so the mean value of x is that and mean value of y is that. Therefore the mean point is that. So this one is suitable, is going to be used when you are drawing the line of best fit. So now let's go and draw the scatter diagram. So for the scatter diagram, you need a graph paper. Then you have on the graph paper, you put there the axes, horizontal and vertical. Then you label the axis, you put the scale for the horizontal axis and also for the vertical axis. So for the horizontal axis, you have to also label the axis. Then for the vertical axis, you shall get the scale and also label it. Then after that, we shall now start plotting. Now plotting, we shall plot A is 51 corresponding with 45. So 51 horizontal, 45 vertical. So that is that point. Then next is 62, 54, which is that point here. Then next is Next is 64, 58, which is that point. So let's first remove this, which is this point. Then next is 47, 46, which is that point. Then next is 54, 49, which is that. Next is 44, 43, which is that. Next is 68, 59, which is that. Then next is 61, 56, which is that. Then next is 56, 53, which is that. So that is what we call the scatter diagram, but they told us also draw a line of best fit. So what we are going to do, we add there this mean point, which is 56.3 and 51.4. So that is the coordinate of the mean point. Then next we draw a line of best fit. Now line of best fit must pass through the mean point and any one or more points, provided leaves equal or almost equal points on either side. So when you follow that, we shall get our ruler and draw the line of best fit passing through those 2 points, passes through this mean point and this point. So most students, what they do, they just draw their line of best fit passing through in the middle of the points without passing through directly in the point. So for example, if this line doesn't pass through this point or any other point, it means that's not a correct line of best fit. Then to it must leave equal or almost equal points. So if I look at this side, to be 1, 2, 3, and 4. So it has left 4 points on this side. What about this side? 1, 2, 3, 4. So that is a correct line of best fit. The next is to use the line of best fit, because here they told us that use the line of best fit to estimate the value of x when y is 55. So we are going to come here and look for 55 on the vertical axis, then take a horizontal line there. Then where it meets this line of best fit, we take a vertical line downwards to meet the horizontal axis. Then we shall read off that value, and that will be the value of x. Therefore, we shall come and state that when y is 55, x is 61.75. Then part C, the one that is Spearman's rank correlation coefficient. So this is the formula. It is also available in the mathematical tables. So after that we shall substitute. Remember, summation of d squared was 4, then n was 9, because there were 9 students. Then so we substitute for n and for summation of d squared, which is that. The next is to use the calculator to come up with 0.9667. After that we have to comment. So the comment is, you choose one comment. You can choose the significance at 5% or at 1%. So at 5% it is significant, and also at 1% is significant. Now why is it significant at 5%? So you come here. Remember, the calculated value is 0.9667, and when I look at the table value, the pair of 9 takes me here. For 5% is this. So in this case, the calculated value, which is 0.9667, is greater than this table value, meaning it has to be significant. Similarly, if you look at 1%, the table value is 0.9667, and this one is 0.83. So the calculated value is greater than the table value, meaning it has to be significant. So that's how you can know that it's significant or insignificant. So basically that is what they wanted. So B1 for the mean point, B1 for the axes, both vertical and horizontal, B2 for plotting all points correctly, B1 for the line of best fit, M1 for the estimation line, A1 for the required value of x, M1 for substitution, A1 for the output, and B1 for the comment. So it should be one comment, either this or this. So that was question 9. Now we shall go to question 11, which says, Part A, given that alpha and beta are roots of the quadratic equation, this show that alpha plus beta is 3m and alpha beta is n squared. Then part B, if alpha and beta are the roots of the equation this, find part A, the values of alpha squared plus beta squared, and part Roman 2, the value of 1 over alpha squared plus 1 over beta squared, and Roman 3, quadratic equation whose roots are this. So let's start with part A. So part A, we know that the roots are alpha and beta, so x is equal to alpha and x is equal to beta. The factors will be x minus alpha. When I take this one this side and also this one this side, I got this factor. Because they are both equal to 0, I can multiply the two and equate them to 0. Then when I expand, open brackets, I'll come up with that. Expand further, I'll come up with that. Then when I collect the like terms, this one will give me that. Then from there, I'm going to compare with the given equation, and realize that alpha plus beta is 3m and alpha beta is n squared. So basically that is what they wanted. So m1 for factors, which is that, m1 for product of factors, which is that, m1 for opening brackets, which is that, m1 for factorizing, which is that, b1 for required sum, another b1 for the required product. So part B, they said this, if alpha and beta are roots of this equation, find Roman 1 alpha squared plus beta squared, Roman 2 1 over alpha squared plus 1 over beta squared, and Roman 3 find the quadratic equation whose roots are 1 over alpha squared and 1 over beta squared. So for Roman 1, we shall say that this was the given expression. Therefore alpha plus beta is 9 and alpha beta is 4. Therefore alpha squared plus beta squared is given by this expression in terms of sum and product. Therefore I'll come and substitute. Sum is 9, product is 4. Therefore I'll end up with 73. Then for Roman 2, this one I'll have to first get the LCM. LCM of this is alpha squared beta squared. So this LCM divided by alpha squared, I'll remain with beta squared, multiplied by 1, I'll remain with beta squared. Then this LCM divided by beta squared, I'll remain with alpha squared times 1, which gives me alpha squared. But I already know that alpha squared plus beta squared is 73, so I'll come and substitute for this as 73. Then alpha squared beta squared is the same as the square of alpha beta, which is 4 squared. So this gives me 73 over 16, which is 4.5625. Then Roman 3, one of the equations. So before you get the equation, you have to get the product of roots. We already know the sum of roots, which is this, but the product of roots, you have to get it. So product of roots is that 1 over alpha squared beta squared, which gives you 1 over 16. Then from there, I can now quote the formula for the quadratic equation. Then I substitute sum and product. Then I can multiply throughout by the LCM. So basically that is what they wanted. So M1 is for this expression, M1 for substitution, A1 for the output. A1 for this expression, A1 is for the substitution, A1 is for the output. M1 is for this substitution, A1 is for the output. B1 is for this equation. So that was question 10. Now we shall go to question 11, part A, which says, given that M is that, N is that, K is that, and K is equal to M plus N, find the values of X and Y. So let's first do that part. So I told that k is equal to m plus n, so I'll come and substitute for k, for m, and for n. Then I'll simplify this, adding these two matrices. This plus this gives me 4x minus 1. This plus this gives me positive 4. This plus this gives me negative 2. This plus this gives me negative 2x plus 3y. So next is to use the knowledge of equality of matrices. So this is equal to this, which is that. Then also this is equal to this, which is that. So those are two equations, two unknowns. What I'm going to do, I'll substitute for y here to come up with this step. Then I'll open brackets and I'll remain with one unknown. So when I collect like terms, 15 will be equal to 10x, and therefore x is 1.5. Y will be got from here, which will be 5. So basically that is what they wanted in part A. So M1 is for this substitution, M1 for addition, B1 for equating, equality, M1 for solving, A1 for the value of x, M1 for substitution, A1 for the value of y. So that was part A. Now part B. In a football tournament, 3 teams, Arsenal, Chelsea, and Liverpool, had the following results. Arsenal won 2 matches, drew once, and lost 1 match. Chelsea won 2 matches, lost 2 matches. Liverpool won 1 match and drew twice and lost 1 match. The teams are awarded 3 points for a win, 1 point for a draw, and no point for a loss. Roman 1. Write a 3x3 matrix for the results and a column matrix, know this word, column matrix, for the points. Then part B, by matrix multiplication, determine the winner of the tournament. So the 3x3 matrix is that, then the matrix for points is that. Therefore, by matrix multiplication, we are going to multiply using the correct order. So start by 3x3 followed by column matrix. So come up with 7, 6, 6. Therefore, the winner was Arsenal. So B1 for the correct order and B1 for the correct entries. B1 correct order, B1 correct entries. M1 for this correct order of multiplication, B1 for the outputs, and A1 for the, B1 for the final output. Then A1 for the conclusion. So that was question 11. Now we shall go to question 12, which says a discrete random variable x, so this was supposed to be x, has a probability distribution shown below. So this is a distribution, part A. Find the value of D, part B. Find the probability of x greater than or equal to -3 but less or equal to -1. Then part C, probability of x greater than -1. Part D, Roman 1, this mod Roman 2 mean Roman 3 variance of the distribution. So to get an unknown constant, you have to remember that total probability is equal to 1. So when I add, I'll come up with equality to 1. Simplify and get the value of D as 0.2. Then for part B, they want this probability. So probability of x greater than or equal to 3 means that you start from -3, then there is -2, then there is also -1. So you add all those ones. That will be this probability. So the probability of x equal to -3, you'll get it from this table. So -3 is 0.1, -2 is 0.25, -1 is 0.3. So come and add all those ones, and the answer will be 0.65. Then part C, the probability of x greater than -1. So greater than -1 will be 0 and 1 if you look at this table. So you look at this table, greater than -1 to be 0 and 1, and the probabilities are 0.15 and D, which is 0.2. So you come here and substitute, which will be 0.15 plus 0.2, which is 0.35. So basically that is what they wanted. So M1 for this substitution, A1 for output, M1 for this substitution, M1 for additions, then A1 for the output, M1 for additions, and A1 for the output. Then they wanted here mode, mean, and variance. So mode is the value of x whose probability is the highest. So in these values, it is 0.3 which has the highest probability. Therefore, mode will be -1. And we shall now come here and say that mode is equal to -1. Then for the mean is equal to x multiplied by corresponding probabilities. So when I do that, for -1 probability was 0.1, -2 probability was 0.25, -1 probability was 0.3, 0 probability was 0.15, and 1 probability was 0.2. So when I simplify, I'll come up with that as my value of probability. Then for variance, it is, you have to first get EX squared. So EX squared is equal to x squared multiplied by the corresponding probability. So those will be the values. Simplify and be able to come up with this. But this one is not the variance, it is just EX. So after getting EX squared, you will come and say that var x is equal to EX squared minus mean squared. So EX squared is that and mean is that, so I have to square the mean to come up with the output, which is 1.59. So that 1.59 will be the variance. So A1 for the mode, M1 for substitution, A1 for the output, M1 substitution, M1 for addition, and A1 for the output, M1 for substitution, A1 for the output. So that was question 12. Now we shall go to question 13, which says the gradient function of a certain curve is dy dx equal to 2x minus 5. Part A, determine Roman 1 the equation of the curve given that x equal to 0 when y is 6. Then Roman 2, the coordinates and nature of the turning points on the curve. Then Roman 3, x and y intercepts. Then part B, sketch the curve and hence calculate the area between the x-axis and the curve. So this is, you are given the gradient function. To get to y, you have to integrate. So when I integrate this, I'll be able to come up with, so 2x gives you x squared and 5 gives you 5x. Then after that, remember to add the constant of integration. Then remember that we are told that when y is 6, x is 0. So I'll come and substitute for y and for x. Therefore c will be 6. And therefore I come and substitute for c in this equation to get the required equation. So that was Roman 1. For Roman 2, for turning points, dy dx is equal to 0. So I'll get this dy dx and equate it to 0 to get the corresponding value of x. Then the corresponding value of y will be got from this equation, and that will be negative 0.25. Therefore come and say that the turning point is 2.5, negative 0.25. Then for the nature, I have to differentiate the second time. So differentiate the second time, I get 2. Differentiate this the second time, I get positive 2. Because it is positive, it implies that this turning point is a minimum. So before I go to the next slide, let's see marks for this slide. So M1 will be for this integration, A1 for the required equation, B1 for the x value of the turning point, B1 for the y value of the turning point, B1 for the coordinate of the turning point, B1 for the nature. So Roman 3, they wanted the x and y intercepts. So the x and y intercept. So for the y intercept, x is equal to 0. So when x is equal to 0, y will be 6. Therefore, the y intercept will be 0, 6. Then the x intercept is y is equal to 0. Therefore, this will be equal to 0, and this is quadratic. So we can factorize and get the corresponding values of x. Therefore, the x intercepts are 2, 0 and 3, 0. So part B, they wanted you to sketch the curve. So you have to draw the axes and label them. Then next also draw the, locate the intercepts. Then also the turning point, and then the shape has a minimum. Then you also label the curve. So basically that's what they wanted. Then next was the area. So before we go to the area, let's see how much can be awarded. So this B1 is for the y-intercept, B1 for the x-intercepts, B1 for the axes, B1 for the curve well labeled, and B1 for the intercept seen. Then for the hence part, area is equal to integral of y from 2 to 3. So y was this, therefore when I integrate this, I'll come up with this. Then substitute the limits, start with the upper limit to give you this bracket, followed by the lower limit to give you this bracket. Then simplify to come up with -1/6. So what does that mean? It means that the required area is 1/6 square units below the x-axis or above the curve. So basically that is what they wanted. So M1 for this definition, and M1 for integration, M1 for substituting limits, A1 for stating the area. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on S5 Physics Paper 1 of beginning of Term 3 exam. So if you haven't yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on physics has been uploaded. Otherwise, thank you for watching, and also if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.